Sine, cosine, and tangent are the main functions used in trigonometry, and these are based on right-angled triangles. So before we get stuck into the functions, it helps to name each side of the right-angled triangle. So we know that the right-angled triangle is easily identified by the right angle, which is 90 degrees, to one corner of the triangle. And the hypotenuse is always the longest side of the triangle. The hypotenuse of the right angle triangle never changes. So the longest side, which is the side opposite the 90-degree angle, will always be your hypotenuse. Now let's take a look at the angle on the triangle displayed. The opposite side is always opposite to the angle, and the adjacent side is always next to the angle. Now, if we shift the angle in question, we can see how the opposite side now changes and the adjacent side now changes. Again, the opposite side is always opposite the angle and the adjacent side is always next to the angle. Now we'll take a look at sine, cosine, and tangent. And these are each ratios of sides of a right angle triangle. The formula to calculate sine is opposite over hypotenuse. So, starting at the direction of the angle, we look at the length of the side opposite the angle and we divide it by the hypotenuse. The second ratio we would look at is cosine. The formula to calculate cosine says adjacent over hypotenuse. Starting from the direction of the angle, we look at the side that's adjacent to the angle or next to the angle, and again the hypotenuse always remains the same as the longest side of the triangle. The last ratio that we would look at is tangent, and the formula to calculate tangent says opposite over adjacent. Starting from the direction of the angle, we look for the side that's opposite the angle, and then we look for the side that's adjacent to the angle, and we divide it. An easy way to remember these formulas is known as SOHCAHTOA. SOHCAHTOA. So it's really easy to remember if you make a little sound out of it. SOHCAHTOA. So stands for the ratio sine, and the formula is opposite over hypotenuse. Ka stands for the ratio cosine, and the formula is adjacent over hypotenuse. Toa stands for the ratio tangent, and the formula is opposite over adjacent. Now let's get into some examples. The diagram below shows a quadrilateral PQRS where PQ and SR are parallel. SQ equal 8 centimeters and angle SPQ is equal to 90 degrees. Angle SQR equal 82 degrees and angle QSR is equal to 30 degrees. The name of the angle is simply 3 letters representing 3 vertex points, and the vertex point is always listed in the middle. So therefore, angle SPQ would be this angle. Angle SQR would be this angle. And angle QSR would be this angle. Question 1 says, determine the length PS. Let's consider triangle PQS. PQS. Because this is 90 degrees, we know that this is a right angle triangle. We are required to calculate the length PS. We know that the length QS is 8 centimeters, but we need to know the size of angle PSQ or angle PQS. Alternate angles, sometimes referred to as Z angles, state that these two angles are always equal. So looking at our quadrilateral PQRS, we can see that there's a Z angle right here. Therefore, this 30-degree angle is equivalent to this 30-degree angle. So we can safely say that angle PQS is 30 degrees. Now that we've located the angle in question, we can draw lines. So we are required to find the side opposite the angle, and we know the hypotenuse. Again, the hypotenuse is the longest side of the triangle. So which one of the three formulas uses opposite and hypotenuse? So, which is sine. So sine the angle is equal to opposite over hypotenuse. So therefore, sine 30 degrees is equal to PS over 8 centimeters. Now, we take the 8 centimeters and we carry it over the equal sign. It would now become sine 30 degrees. Because it was divided on one side, it will now be multiplied by 8 centimeters is equal to PS. Now we go to our calculators and look for the sine function of 30 degrees, which is equivalent to 0.5 multiplied by 8 centimeters is equal to side PS. 0.5 centimeters multiplied by 8 is going to give us 4 centimeters is equal to side PS. Part 2 of the question says to determine the length PQ. So again, I'm going to draw over the triangle. We have our 90-degree angle. Label this as 30 degrees. Our points P, Q, S. Side QS is 8 centimeters. So again, we're going to label our triangle. And the hypotenuse, as we said, will always remain the same. And now they want us to find the length of PQ, which is the line adjacent to the angle. Which one of the three formulas has hypotenuse and adjacent? Ka, which is cosine, adjacent over hypotenuse. So cosine is equal to adjacent over hypotenuse. So therefore, cosine the angle of 30 degrees is going to equal to PQ over 8 centimeters. Cos 30 degrees is going to equal to PQ over 8 centimeters. So again, we're going to take the 8 centimeters and we're going to bring it over the equal sign. So now we have cos 30 degrees. It was divided on the right side of the equal sign, so now it will be multiplied on the left side of the equal sign. Multiplied by 8 centimeters is equal to PQ. Now we go to our calculator and we look for cosine 30 degrees, which I would round off to 0.866 multiplied by 8 is equal to PQ. So therefore, 6.9 to 8 centimeters is equal to PQ. Hopefully this was clear and hopefully you understood. Until next time.